You think that's fine that we're just in the waiting room?
Yeah, it's chill.
All right, all right. All right. So, yeah. So I would. Should we take a moment and kind of, if you'd like to speak up, we've got actually more people where I think we could. If you want to say kind of how where you're at, I would like if in either in the text chat box or whatever, or unmute and talk for a second. Go ahead. It's kind of like whether how far you are, like I don't know what your history is, like yeah, just kind of depending on whether we're more or less advanced, I'll kind of go quicker or slower. Never heard of Solidity.
Hi, I've been making video games for a while now, and I've been making games for Android and iOS, and I always want my company to make a game on the blockchain. So I started studying how to make that games on with that has that access, right, with for blockchain. So I started doing tutorials online, and I made crypto zombies. I completed. There was one. Let me find the one I was. Really, it's been a while since I've opened that page. Just let me. Well, I don't remember the other one, but I've been doing some courses online, but I still feel like I'm pretty new to this world, and it's really frustrating for me because I can't seem to find where to learn all of this, like the precise.
Yeah, I definitely think learning Solidity is like the best, like I don't know, obviously I'm biased, but I think it's like the best possible thing you can do as like someone who can code or program. It's like one of the most interesting languages you can learn right now because it's only been around for like a handful of years. And so you can kind of be at like the most elite edge of this new language, even regardless of how much like experience you have as like a programmer. Yeah, reading kind of the other responses in the chat. Ivan, I'm hoping I'm saying your name right, is read about 100 pages of Solidity docs, which is pretty sweet. Evan can read and write, hasn't deployed nor implemented much. Maxwell, front-end dev, few Solidity projects, basically new. Okay, so I think I'm going to kind of go ahead, unless I don't mean to be cutting someone else off. They'd like to unmute and talk. Okay. I am going to kind of take the like assumption that you guys are like maybe know a little bit. I'm happy to explain things if you at any point just kind of like stop and ask questions, go ahead. But I'm going to assume you've at least looked at it like a tiny bit. And this would be like the perfect resource if you've like done a little bit of crypto zombies or whatever, but you kind of need to take that next step and like, okay, well, how do you actually start doing stuff? But even if you haven't, done crypto zombies or have even started it, this will still be like a palatable resource. So I have the start of a little presentation to start with. Can everyone see okay? Yep. I'm assuming, yeah, okay, cool. And again, just like stop and ask questions at any time if you want. So we're going to be talking about Ethernaut level 4. Ethernaut is this really cool CTF. A CTF stands for capture the flag. And essentially what you do is, or it's common like all across programming where people set up like some sort of program or whatever that has like a vulnerability in it. And they call it the flag, and then you hide it somewhere in the program, and you as the hacker have to go exploit the vulnerability and try to steal it. So it's a really good resource because it teaches you you get like good programming experience because you have to like actually look at things from like a very like practical and like professional level. And then it also kind of hardens your like security knowledge because then you understand what like possible mistakes you can make and how to avoid them. And especially with like something like Ethereum, it's like in order a lot of the challenges you face or flags or whatever levels go pretty technical. So they're great to look at and understand Solidity on like a deeper level. And it was made by OpenZeppelin. OpenZeppelin you probably have heard of. They're a blockchain security company. They audit a lot of popular contracts, and maybe even more popular is they create these libraries of community vetted contract elements. So like most like ERC20s, which are like, coins that are traded on top of ETH, are based off of Open Zeppelin standard. Because if everyone's like, there's tons and tons of ERC20s, but if every single person has to code that from scratch, then it's inevitable that we're going to run into a lot of people who, have flaws, bugs, whatever. And so it's easier if everyone can kind of borrow the same code and reuse it, because it's safer, because the community's looked at it hundreds of times. And so Open Zeppelin kind of has like the best resources for that. They've got like ERC20 standards, like Merkle tree stuff, like just about everything. I should have linked to their GitHub, but it's a cool resource to you'll probably use as you do dev work. And I just realized I should probably send this presentation in the chat. I'll put it in Hash General if anybody wants to. Yes, copy link done, and I'll put it in the Discord. Put it in developer. All right. And it's specifically made by this guy Alejandro, who is at the Ethernet on Twitter. He's a really good guy to follow because he talks about a lot of low-level Solidity stuff, and it's just kind of a high alpha individual. So I'd give him a follow because he made most of this from scratch just by himself, which is pretty sweet. All right, so specifically we're doing Ethernet level 4, which is called telephone. Each one has a name. Prerequisites, you know a little bit of Solidity knowledge. You have MetaMask probably set up. You guys know what Rinkeby is, or what like testnet is? Yeah. Okay. So, generally if you're, generally if you're working on Ethereum, you don't want to be testing in prod, as Andre Cronje would say. You don't want to constantly just be like deploying everything for the first time ever, and paying like real ETH for it and like deploying it in real life, because people could start using it and it could have bugs. You could lose a bunch of ETH. Deploying is super expensive. You can deploy contracts for like thousands of dollars, so it's not very efficient to like test on mainnet. So there's some alternate chains, one of which is called Rinkeby. There's also like Goerli, Kovan, like a bunch of other ones where they're just like non-decentralized versions of ETH. Yeah, 0.3 is probably enough. And for people to just play around on. So you can get like free ETH to play around with. Sorry, I keep getting distracted by notifications and things. Go and deploy contracts and mess around with them without actually risking any funds. So you can get testnet funds. They'll send you free ETH from different faucets. It's called faucets because they just leak ETH. The best one, in my opinion, is the Paradigm one. Paradigm is a research firm / venture capital group that are just filled with chads, and they have a really nice faucet that just kind of gives you like every testnet at once. There's like a more popular faucet, but I think it's been broken and like goes down like all the time. So just use this one. And if you haven't started learning Solidity, Crypto Zombies, in my opinion, is the best resource. Crypto Zombies is it's like this old kind of like fun style, like you kind of make this game where you train zombies and then like battle them together. It's like a ripoff of like Crypto Kitties, if you've heard of that, which is like an NFT collection / like Pokemon kind of ripoff. But it's good because it kind of covers all the major like kind of functions, and it's just like widely considered like the best resource, even though it's kind of goofy. So it's recommended you start there if you haven't touched Solidity yet. And it's pretty, you can move through it pretty quickly. I would say towards the end, it starts trying to teach you JavaScript, which is important to Web3 because you need to, ultimately your front end for your Solidity contract is going to be in JavaScript. So you need to learn it. But if you haven't learned JavaScript before, then that part of the tutorial is really hard because you kind of have to like go back and learn the entirety of JavaScript mid-tutorial. Yeah, so Okay, sorry, I'm still, I shouldn't have set up the, I don't know, the waiting room makes this hard. Can I, yep. Okay, so this is what the actual, and it doesn't help that I have like 4,000 like different Zoom menus and I have to like navigate all around them. This is what Ethernet actually looks like. It's got, it's just kind of like hosted on the Open Zeppelin website, and you play the whole thing through the console, like the dev console. If you've ever done like inspect element, that's kind of what you're talking about. So glad they don't show your password. You connect your MetaMask to it, then you open up the dev console, and then you interact with the contract through the dev console. It looks super flashy, but it's just like they just make it look cool because you end up spending a lot of time here. Essentially every level it'll be like, this is the telephone level. It'll show you in like rainbow letters. And then they inject a bunch of like functions that you can access through the console. So like if you type like help, it gives you different like functions that you could use. Like get balance would like return your like ETH balance, and like from way to way like converts your like ETH into like the smallest division of ETH that I was talking about. If you read my like message about the guy who lost all the money on the rock. But I'm gonna just shrink this there. Okay. So we're gonna go ahead and go to level 4. And we're gonna hit get new instance, which is going to deliver us a new version of the level. Okay, so every single level is a smart contract. So you're hacking like a real smart contract. And so you have to hit, get new instance because it's actually deploying a contract for you. And you have to like go get it. Okay, so I hit get new instance and it popped out this instance address, which is 1A53E, whatever. That's the address of that is the address. Sorry, I keep pausing because I'm trying to find a way to like organize like 10,000 Zoom windows, and I can't find out a good way to do it because there's like everything, but I think I'm good. This is the location of our contract that we're going to be hacking on Rinkeby. So I hope you guys have seen Etherscan before. Etherscan is kind of scan, except now it's pinging Rinkeby instead of mainnet. So I can plug in. I'm getting a message that my internet is unstable. Can you guys hear me still?
Yeah, you cut off.
Yeah.
All right.
Yeah, you can.
We're on Rinkeby Ethernet, or holy crap, Etherscan Rinkeby. I'm plugging in the address for the contract that we're told to hack, and you can see it right here. So this is kind of what you'd be using if you ever wanted to like go read the source code of a popular contract. You'd just be plugging in their address into Etherscan, and then you can actually go read through it. It's the same as the one that they list right here. So we're going to go ahead and go through this line by line. Make sure that it didn't. Yeah, okay. So holy crap. First line of so this like, the source code over here is the same as the one that's actually deployed to the actual like Rinkeby network. We'll go ahead and read it from here because it's easier. If you guys have already kind of finished Crypto Zombies, you kind of see the skeleton of a Solidity contract here. First line is it identifies the license that we're using. This is the MIT license. This kind of just outlines like who can copy the code and in what terms. But generally you can just ignore that because it's just like a bureaucracy kind of thing. Here we have the pragma for the Solidity version. We're using Solidity 6. Current version of Solidity is like 8 something. So this is pretty old. The CTF was made like, I want to say like 4 years ago or something like that. So it's back on like an outdated version of Solidity. But it's pretty much the same for the most part, so that doesn't really matter. Here we have the body of our contract. Solidity is a curly bracket language, which means that everything is scoped based on the curly brackets. So, this is the body of our contract. Contract's name is telephone, and inside we have a public address called owner. We have a constructor, which is our first function, that sets that variable owner to message.sender. Are you guys familiar with message.sender? Yeah, message.sender is the like person who sends the actual message, like who calls the function essentially. So if I were to call this function from my MetaMask account, that would be my address. Then we have our second function, which is called change owner. And it takes one parameter, which is an address called _owner. It's also a public function. It does a check that if transaction origin is not equal to message sender, it sets owner. Otherwise, it doesn't do anything and it just returns. And at the top of this whole thing, it says our goal for this, this flag, this level, whatever, is to claim ownership of the contract. So what that means is we need to make the owner equal to ourselves. Does that make sense to everyone? Okay. And just to kind of show off this like console thing, this is JavaScript, so don't worry about it too much because this is a Solidity thing. But if you went and actually asked the contract for the owner, you would get 0x0b65 6f whatever, which is the contract that deployed this. So when we hit get new instance, this address right here went and deployed this contract for us. So we need await contract.owner to return my address, which is leet something, instead of what it currently is. So does anyone have any ideas on how we can go about doing that?
We just call change owner with our address.
So if we call change owner with our address right here, right, and we input, our address as this parameter, that's what you're saying, right? We could do that like this. Change owner, and then we plug in my address for it. That will, I think I might have to actually like format the address or something like that. I'm not great at JavaScript, to be completely honest, so I make mistakes a lot. This will, we can send this and we can try, but then in this if statement, transaction.origin is, I should have explained, but I also don't really want to give it away. Transaction origin represents where the function call was sent from, and where it like originated, which the whole hack here, and it looks like Bryson got it, is different than message.sender. So here's it. We finally had our transaction mined, which means if we wait for this again, it's still, you can see that the owner didn't change. Our transaction went through, but the owner didn't change because we didn't get inside this if statement. So we need to come up with a way to make transaction.origin not equal to message.sender. So, and as you guys are in the chat are kind of finding out, I had this big page to prevent me from skipping this slide, so I didn't give it away. It's got a Smurf that says no peeking on it. You would go and probably, research, what is message.sender, what is transaction.origin, what are the differences, and how can I exploit that. And so this is a great Solidity Stack Exchange or Ethereum Stack Exchange is, just Stack Exchange that is optimized for Ethereum. And this is a pretty old post. It's back in the day when Vitalik Buterin actually hung out on Stack Exchange and answered people's questions, which is kind of crazy when you think about it. The guy asks, if we're in the body of the Solidity function, we have these two things, set owner is message.sender, and owner is transaction.origin. Like, what's the difference? And this guy explains it pretty well. He says, message.sender the owner can be a contract, but with transaction.origin, the owner can never be a contract. In a simple call chain, A, B, C, D, inside D, message sender will be C. So like if you're calling a function in D, sender will be C, and transaction.origin will be A. So I go and talk about this. I say, transaction.origin is the origin of the call. That's the first person who initiated the whole chain, in our case, A. And message.sender is the thing that most directly or immediately called that function. So if we're calling a function in contract D, and we have A is like me, and then B and C are contracts, and B is a function which calls a function in C, which calls that function in D, which we actually care about. A will be the origin of the transaction or the call, but C will actually be the sender. Does that make sense? Okay. And this was kind of like a big deal when Ethereum Serenity was originally coming out. You can see this was asked 6 years ago. And Serenity was like kind of like the original name for like ETH 2.0, like proof of stake, like whatever, which has changed names like 100 times. They're not even calling it ETH 2 anymore. And it's funny because I was like clicking around on this and it's like, oh, hey, look who like answered this question. It's like Vitalik himself, straight off the cover of Time. But it's kind of funny to think about. It's a cool history lesson. Like they've literally been trying to upgrade for ETH 2.0 for like 6 years, which is a little bit ridiculous, but it's very gradual. Okay. So we know that we need to make the origin of the call different from the contract that actually calls it. So Bryson said in chat, we need to route transactions through another contract to get transaction origin to be different message.sender. So how should we go about doing that? What's the best way to route the transaction through another contract? I guess that's kind of a bad question, but I guess I'll answer it myself. So we need to deploy a contract, which is going to be calling change owner itself, and then call that contract, our like helper contract, our hacker contract, ourselves. So we're going to deploy a contract, which is going to call change owner for us. So that transaction.origin will be us, and then message.sender will be our hacker contract. Does that make sense? Okay. So if you haven't deployed a contract before, this is Remix. I'm going to make a new contract here. Remix is a really sweet resource. It's a IDE, which is like an integrated developer environment, kind of like Visual Studio or VS Code or whatever. Except it's totally optimized for Ethereum and it's made by the Ethereum Foundation. So a lot of people kind of meme on it because it is, it's like an online version, like IDE, which is kind of, you would assume you would never do anything serious with it, but it's actually like a really nice resource because it's so well created and because it just makes everything easy. So it's great for small projects. But it's also great, like even as like a professional, if you're working kind of in the software smart contract dev space, like a lot of the pros use Remix. Like I feel like every few days on Twitter, I hear about some like absolute Solidity Chad like using Remix, and it's at first it's kind of surprising, and then after a while you're like, oh yeah, like I get why they like it so much. So over here on the left, I don't know if you guys are familiar with programming, you've kind of seen this kind of format before of like what like an IDE looks like, but if this is new to you, I'll kind of try to explain it anyways. We've got a folder with contracts in it, which is where we can actually store contracts or smart contracts that we've written. Scripts is where we can have like JavaScript scripts that like interact with the chain. Tests is the same. We can write tests in Solidity or JavaScript, which like make sure that our contracts are doing the correct thing. I think they talk about that in Crypto Zombies a little bit. They're like, yeah, you should always be testing your contracts to make sure that they actually do what you want before you put them out on mainnet, which is good advice. So we're going to make a new Solidity contract. We're going to call it. Actually, I've already done this once, but I don't want to spoil it. So I'm going to rename. Oh man, tried so hard. And I'm going to make a new contract called Solution. Solution.sol. Okay. You guys are welcome to. I assume it'd be kind of hard to follow along because you'd have to set up like your whole Ethernet setup and whatever. So I'll just go. But first, it's going to whine on us because we don't have a SPDX a license identifier, which we're just going to ignore. We're going to go straight into our pragma, which is where we define what Solidity version we're using. We're going to use Solidity version 8 just because that's the most, like it's more recent. Even though the contract, if you might remember earlier, this one's in Solidity version 6, but we don't really care. A version 8 contract can still interact with a version 6 one. Whoops, I forgot the word Solidity. That's nice. Okay, next we kind of have to have our contract itself. We're going to name it hack. And so now we need to go about actually like interacting with the other contract. So we need something in order to go. Sorry, question. Are all the mainnet contracts available to, can you guys hear my washing machine? Sorry. Are all the mainnet contracts available to interact with on the test nets, or would you have to copy them over? Good question. So generally when you're testing, you test in kind of one of two ways. You have testnet, which is what we're currently using, which is it's like a complete like alternate universe where none of the existing contracts that are on mainnet are there. So if you wanted to be interacting with something like Uniswap or something like that, you'd have to go deploy Uniswap on testnet in order for it to like actually be on testnet. Anything that's not there. Sorry, I'm distracted again. Is someone needing something in the Discord? Is there anybody locked out or in the waiting room or something like that? We good?
And then also if you release something on these test nets, are they going to stay there forever and do like a clean every once in a while, or how does that work?
I think it's totally up to the people who are actually running the testnet. I think they have had resets historically. But I think that's pretty rare. Essentially, it's just like all of Ethereum running on like one computer instead of like a totally like decentralized, like, there goes one person. Instead of like a totally decentralized like network of like thousands of computers. And before I trailed off, the other way that you would test is you would instead fork mainnet. This means you copy all of mainnet over to a exact copy of Ethereum, and then you run that blockchain locally and test on top of that. And then if you did it that way, then you would in fact have all the contracts that were deployed because you had the entire state of Ethereum copied over. Does that make sense? Okay. So
incentive for them to keep the testnet running?
It helps. There's no real incentive. It's just kind of like it's to encourage like production, to encourage like research or people to build. Like it just makes Ethereum a lot easier, like nicer to work on if you have that kind of resource to work, whatever. So it's kind of like it's just like an educational resource. Or so I think the people who run them are like the Ethernet Foundation. So someone like I don't think Paradigm does, or in fact they don't, but like they're someone who would, because they like care a lot about like research and like stuff like that. So it's just out of the kindness of their hearts / to incentivize usage of like the actual network. And most networks have this. Like there's like if you were on like what is it, Polygon, like there's like a test Polygon, which has some weird name. I think it's called Mumbai. Yeah. Okay. Moving on then. in order to interact with our contract, which is, we currently have my MetaMask set to Rinkeby, right? So I'm interacting with the Rinkeby contract that is on Ethernet. If you've ever messed around with like other networks or whatever, you can choose between on MetaMask or whatever you're using, you can connect to a number of different networks. And as long as you're just Ethernet's hosted on Rinkeby, so you connect to Rinkeby in order to interact with the Rinkeby contracts. Okay, so in order to interact with that contract, we need to have something. Do you guys know what that is? There's technically a number of ways that we can call functions of another contract. But the easiest way to do so would be through an interface or import another contract. Yeah. Inherit and import. Yeah. Good answers. We could do this two ways. One, we could take this whole contract, right? And we don't want to have the double pragma, so we ignore that part. And we could dump this into our contract, right? So now we have, this would be the same as like importing it, right? We've actually dumped the contacts or the contents of telephone into our contract, so hack can see all of it, because it knows what telephone is, and it has its own kind of local one. The other thing that we could do is we could just have an interface, and this is in most cases preferred, because it you don't have to have the whole contract there. You can just have the relevant parts. And so with an interface, we can get rid of the constructor and this owner thing. And we can just say, hey, there's a function called change owner. We don't have to care about the contents of it. And we can just say, it looks like that. I'm missing something. And all functions of an interface have to be declared external instead, because an interface isn't able to call functions itself. Does that make sense? Okay, so now we know hack has this interface telephone where it knows what functions telephone has, in this case, change owner. And it doesn't have to import the whole thing. And we don't have to know anything else about the contract. That's kind of the whole beauty of interfaces. We don't have to know what change owner actually does. We don't have to know about the functionality of it. We just need to know it exists so that hack can call it. The second way that you could call functions is a more low level way. You could, there's a actual function like EVM function itself, like Ethereum has a function itself that's called call. And that's what you do when you just directly send someone ether. And you can put stuff in the value of the call in order to call specific functions of a contract. But that's a little bit harder. So we'll keep to doing just the interface. Everyone good so far? Okay. I am going to add a construct. So in order to interact with this telephone, we need to actually grab the address of the one in Ethernet, right? So I'm going to copy the level instance. Oops, that's not that one. Instance address, right? So this is the address of this contract. We went and pulled this up on Etherscan, right? We've got all of our code here, which is the same on the Ethernet website. And I'm going to just grab this address. It's the same one that's on the console on the other page. I'm just going to copy it. And I'm going to go ahead and say address pwnme, which is the address that we're going to hack. And I'm going to go ahead and paste that in there. And I think I need to call it. Actually, I don't need to call it public. Okay, so now it has the address of the contract that we're going to go hack. Another way that we could do this, what's maybe a more robust way to add the address that we're going to hack? Instead, we could do it in a constructor where we have something like this. And we could say, we could assign that in the actual constructor and then get rid of this part. Oops. And then get rid of this part. And then this way, if we had a different address for the target, we could it would still work, because we can pass the target in the constructor. Essentially, when you deploy the contract, and on Remix, I've tabbed over to this third tab here. This is where we can actually deploy contracts, and I can now just plug in my target there, and then it'll pass that to Pwn.me when I deploy it. Does that make sense? Okay, if you're new to kind of computer science in general, this might be a little confusing to you. But this is a pretty standard thing if you've done programming before. The constructor is just called every single time that we make this contract. So as soon as we deploy this, it'll call the constructor, it'll take the param that we pass right here, and then it will assign that. Okay, so we're going to do it that way. And then we're going to add another function. And this one's the one that we're going to use to actually go hit the contract and call. So to kind of circle back, what we need to be doing is we need to be calling this change owner function of telephone. So we're going to make a function here. I gotta keep that epic lead speak going. I guess that's technically not lead speak, but we're going to make a function called Pwn. We need to declare it public, otherwise it's going to yell at us. And we need to say, oh, there's one thing I forgot to do actually. Just having the address of the telephone isn't enough. We actually need to initialize it as a telephone object. We need to say, hey, this address is a telephone. So we can say, we have initialized another member variable. Where am I? Okay. We're going to say this is a telephone. Right. And we're going to initialize this phone to like that. So now what we're doing is we're taking this address and we're parsing it. We're casting it to a telephone object so we can actually go and call these functions on it. Does that make sense?
Hey, so if we imported the contract rather than using interface, how would we instantiate it?
It would be just the same. If this was contract telephone instead, we just say, telephone phone. It would be the same syntax, except instead of having this interface here, we'd have the whole contract. If you imported it, it acts the same way. So you can, I believe, just act as if, you had pasted it right there. It's the same.
My question to that is since we're passing in the address to the constructor, what if we define a constructor under the telephone object, wouldn't it run that constructor? Or is that just handled differently? I'm pretty new, so I don't know.
I think it either way. I might be cutting out here. Hello.
I can hear you.
If we actually had this here, is your question how would we get the address of this?
Oh yeah, no. I would say if say under a constructor, we had there was say you could pass an address as a parameter. So if you imported telephone and you put in an address was one of the parameters that you'd use to instantiate it. When you pass in this thing, would it try to make a whole new instance of telephone, or would it
If I understand you correctly, I might be misunderstanding your question, but I think the misunderstanding that you have is we're not actually creating a new telephone or anything like that. We're just taking this existing this contract right here that we've already deployed and already exists and is a telephone, right? And then we're explaining to Ethereum, to our smart contract, what it looks like through this interface or through that import or through that contract. And then in this step right here, we're just saying this address, which already exists before we deploy this contract, is of this type telephone and it has these functions.
I see.
Is that what you were asking?
Yeah. Okay.
Yes, if we, if we're importing, even if we have the full contract there, we're actually not deploying a new telephone. We're just taking the one that Ethernet made for us. Which I could understand how that's confusing, especially if it says contract, whatever, because you assume it's going to be deployed. And it might actually be deploying everything in there. I think when you deploy the contract, Jason might correct me if I'm wrong here, but I think you choose one contract to deploy when you actually deploy a contract. I don't know, it's weird to have two contracts in one file. Yeah. Okay. I'm going to make one more step here to make this a little bit more elegant. I'm going to get rid of the address because really, the only thing we're going to interact with is the address once it's been parsed as a telephone. So we're going to get rid of address pwnme. We're going to make it telephone pwnme. And instead of doing this in 2 steps, we're just going to go straight up. We're going to address that we passed to the constructor, and I'm just going straight to the telephone with it. Does that make sense? Okay. Yeah, I had, and so when we were using the, sorry, did I miss these questions? This is audio cut out. Hopefully I'm back. So when you're using the telephone type, it is from the interface. Yeah, when you're using this, like, we're saying this is a telephone. The only reason we're able to do that is because we have this interface here. If we, and that's in fact the reason why we have it there. If we start to do that, then we're going to have errors. Hey, like we don't have this identifier. We don't know what a telephone is. So we need to include this interface in order to explain what that even looks like. Okay.
What happens if you have like a wrong interface? Like you described it incorrectly?
I think once you actually try to interact with the, like it'll deploy fine and it'll build fine, and the code will look okay. But then once you actually try to use that contract, once you actually say like, hey, we're going to call this function, it'll fail once you actually try to interact with the other contract, because it'll say like, hey, this doesn't actually fit. Yeah. To get more specific, a little bit more advanced, when you say that this is like, what you're defining here is the function signature, which is like, we have a function, it's named change owner, and it takes this parameter. And that's under the hood, that's all the Ethereum virtual machine, which is like, the virtual computer that Ethereum's running between all of its nodes. That's all it needs in order to call a function. You'll say, I have a function named this, and it takes this parameter, and then it like hashes that and tries to call that on a function. So if you do that and that function isn't actually there, you'll have an error. And you won't have an error when you try to build it. You'll have an error once you actually try to do it. Okay, any other questions before I start writing out this pwn contract function, excuse me? Okay, so got to pwn the phone. So this is easy here as just saying we're going to take pwnme. Here's our telephone. Go ahead. Night.
Sorry, it was my mistake.
And says my internet is unstable again. Am I heard okay? Okay. And we need to supply, we know change owner takes a parameter owner, so we need to supply an address. There's 2 ways we could do this, or 2 obvious ways that we could do this. One, I could go grab my address from wherever. I'm just grabbed it from my MetaMask, and I could plug it in right there. Or I could make this one step better, and I could just set it to message.sender. And we've already talked about message.sender. Message.sender is going to be the person who actually, uses this contract, interacts with it, which in my case will be me. So doing it this way is easy, because then it would theoretically work regardless of what wallet I sent it from. It wouldn't work from just, this address that I copied. Does that make sense? Okay. How are we doing so far? It's like too fast, too slow, lost, easily caught up.
It's good.
Okay, sweet. All right, so I am giving this, we should be done. To kind of review everything one more time. We have an interface called telephone. We tell it that we have a function change owner, which is the function that we need to call in the other contract. And we're defining its function signature right there. Then we're going to deploy a separate helper function or contract called hack. It's going to have a telephone, which is going to be a reference to this contract we're going to be hacking. In our constructor, we're going to tell it what our target is, i.e. we're going to pass it the address of the Ethernet contract. We're going to initialize that telephone object that we have. And then we have a function pwn, which is just going to call change owner of the telephone, which is the whole thing that we're trying to do. So we're going to go ahead and compile this. Solidity is a compiled language, meaning that we can't just run this code as is. We need to actually run it through Sol-C, which is the Solidity compiler, and let it go, or let it like get an object that we can then go deploy on chain. Remix makes this super easy, but if you're deploying from somewhere else, it's a little bit harder, which is why we use Remix. We're picking a compiler version here. This is fine. Auto compile, enable optimization, whatever. These are just options for the compilation. Usually you add optimization if it runs through it a handful of times and then like tries to make it more efficient. But that's relevant if you're then trying to publish your code on Etherscan. As a kind of side note, the only reason we can see this here is because Etherscan or Ethernaut went and put this here for us to look at. If we deployed a contract, you can't see the source code by default. You have to have someone go figure out what it is and upload it. And it does that by comparing it to, the compiled object that you have. So whether or not you optimize your contract changes what your like output object is. That might be a little bit too off topic, but then, so I've hit compile, it's compiled. It's yelling at us because we don't have an identifier. Then we're going to choose where to actually deploy this. JavaScript, I think it's just running a like fork of, I was talking about fork versus testnet. I've never actually tried these. I think they're forks. But we don't want to deploy to a fork because then if we, after we've deployed it, it just goes away because we're just running it completely locally on my computer. Instead, we're going to do injected Web3, which means that it's going to actually go through my MetaMask. Injected Web3, like MetaMask's whole thing that it does is it takes all these, parameters and your like access to the Ethernet network or the Ethereum network and like pumps it into your browser. So your browser has access to all those things. So I'm going to pick injected Web3. It realizes that my MetaMask is hooked up to Rinkeby. It sees what address I'm going to deploy from. And I'm going to select the contract that we're doing. I have compiled this twice now, so I don't remember what contract. I think it's this one because I went and solved this earlier. So one of these is the older one. And we're going to pass so we have in our constructed one parameter, our target. So here's where we get the opportunity to actually say what that is. So I'm going to pop back over to Ethernet. I'm going to copy this instance address, which is this one too. We did this earlier. It's the same thing. So now we've, put the target into the constructor. We're going to hit transact. A MetaMask window is going to pop up, same as you've ever done a transaction through MetaMask, except this time it's actually a contract deployment, which you can see here. I'm going to go ahead and confirm it. It's going to take like 30 seconds or whatever to deploy. You can always look at your transactions on Etherscan if you guys didn't know this. It doesn't look quite as nice as mainnet because the Rinkeby network is like less pro the way like the mempool works. We're just going to like refresh this until it finally goes or wait, whatever. And as I guess a refresher, once we have this contract out there, we're not done. We still need to call this function pwn, right? Deploying the contract is one half of it. The other half is actually interacting with it in order to call that change owner function. I'm not sure why this is taking so long.
Can the test network get congested in the same way the mainnet can?
I think it can. It's also like, yeah, like, and like the test nets can like go down too. Yeah, I'm gonna go ahead and just skip that. I mean, it's not gonna get any better because I'm still gonna have to send a transaction from the other one. But I have a deployed contract. I went and made. I have a solution already written. It's this one. I think it's actually identical. Oh, look at me! I'm word for word. Beautiful. And I'm gonna. So I've already deployed that one. So it's already like finished. This. Oh, it's been. Oh, never mind. We got it. It's a success. It took 5 block confirmations, which is wow. My nice license. Oh yeah, license these nuts. Then we can. Okay, so now we're deployed. We have our deployed contract right here. This is kind of where Ether or Remix, so many names, allows us to actually go and call functions of the contract that we just deployed. So we deployed that. Now it says here's your deployed contract. Here's the functions that we have of it. If you had multiple functions, it'd be multiple buttons that we could press. We'll hit pwn. I actually want to make sure that this is the right. I want to make sure that this isn't the old one because I didn't clear out my. So I'm gonna just kind of make sure I'm interacting with the right contract, which is a good thing to know how to do. We're going to look at Etherscan. We're just going to say, oh, we curated this contract 7DED. And when I call pwn, I'm going to make sure that it's actually interacting with that thing. So here, 7DED, right? So I've checked in MetaMask, and this is just good thing to do if you're ever like calling or like doing a transaction. It's always good to like verify your addresses, whatever. So I know we're actually interacting with our hacker contract. And we know we're calling the function pwn. We're going to go ahead and call that. We got another Etherscan transaction to look at. And while that's happening, I guess I can talk a little bit about things. Yeah. Okay, so kind of why you'd want to you should use message.sender instead of something like transaction.origin is because if you have a scenario like this is just some stupid like NFT contract that I've made. I've named it swag NFT. Let's imagine swag NFT as an owner and a transfer function. And if you're making sure, usually you would verify that you're actually the owner of the NFT by having an owner, and you would have a requirement statement that's like you can only transfer it to someone if you are the owner. If message.sender is equal to owner. But instead, if you used transaction.origin is equal to owner, we could another contract. So here's evil coin. I'm so clever. Could have some totally innocent function. And the totally innocent function could actually call your transfer function of your NFT, right? And it could send your stuff to Swag Stealer, which is some address. And so what's happening here is if you don't want to be using message.sender for your verification, because other coins could then call things on your behalf, right? Evil coin, when you interact with evil coin and you call totally innocent, transaction.origin is still you. So if swag NFT is using transaction.origin as the like verification step, then evil coin can just call those functions at will. So this is one reason why you have to be really careful when like anytime you interact with any contract, it's possible that they're not like shoeboxed and like quarantined from each other. You have to be every time that you interact with a contract, you should kind of be subconsciously thinking that like you trust this with your entire account. Does this make sense?
Yes.
Is there any case where you would want to use transaction origin?
I'm sure there is. I haven't thought about it that much myself. I can't think of anything off the top of my head, but I'm sure we could come up with something. Yeah. I think it's also more of a, I don't know. It's just like I think people used it a lot more in like the past when it was less like, there was less security problems and people were like, for a while, like if they're like during this age where Vitalik was just hanging out in the stack exchange, like we didn't really live in an era where people were constantly trying to hack your contract and whatever. Is people just kind of making like gizmos. And so, transaction.origin is still a useful thing to have because it's like a thing that exists in every transaction. So, you wouldn't want to disable access to it from a security standpoint. And so I think a lot of contracts did actually use this, and you probably saw a lot of hacks or stuff like that where they did exactly what we're doing right now. And I had talked about Remix. Again, don't like underestimate Remix because it's a great tool of just about everything. I'm gonna go check to see if this is, yep, okay, our transaction got mined. Yep. So it's weird. Usually I get a notification. I don't know. But our transaction of calling pwn, which if we usually you can see what function you're calling. I'm missing something, but we called the pwn contract or the pwn function now. So if we go back to Ethernaut, we should be set. We should be able to submit this instance, or we should await. We should check first. We should await contract.owner, right? And now you can see we've actually changed the owner to myself. You can see that when this owner variable now is my account instead of the Ethernaut account, which is pretty cool. So we can submit this now. That's another transaction. And if you've successfully hacked the contract, Ethernaut will kind of give you this like victory message. I'm using Firefox instead of Chrome, so it doesn't really appear right for me, but it's kind of fun. There, it gives you this thing. It's like, gives you some face, and this is well done. And so we beat that level. We've got a check mark now. And we're very proud because we're now epic hackers. And then it talks about some stuff where like, why this is important. It's pretty interesting because Ethernaut like replicates a lot of like really popular hacks. Like for example, reentrancy was like, if you guys know about like where like Ethereum Classic came out, there's this whole like debate of like code is law, and like the entire Ethereum chain like rolled back to like prevent this hack from happening, where like billions and billions of dollars were taken from like the first ever DAO. And it's a pretty crazy story if you want to read up on your ETH history. But that's like how you did that attack, and here's how you do. There's like, these are either super common hacks that you should know how to like avoid, or historical hacks that you should know how they happen. So cool resources. You guys should check out Ethernaut. And we have successfully hacked this contract, so good job. Yeah. So here's a picture of our solution. I feel like I've talked about it to death, so there's no reason to talk about it more. Yeah, we just needed to change. We needed to deploy a contract that called that change owner function for us. So that message.sender was not equal to transaction.origin. And that's that. How was that for everybody? Pretty cool.
It's awesome.
Yeah. How is this kind of thing you guys would like to do like more of these?
Of course, I'd like to do more of this. I would also like to make a test game, but maybe or a test. I don't know, something like that. Someday.
Yeah, it'd be sweet if we could get some little projects going. I mean, the club is meant to be a resource to kind of create things. So it'd be great if we had some little projects going. And I think having like a bunch of more technical lessons would be sweet. I think like we really are at kind of like in a good position as like, blockchain at UCLA, because we can very quickly create like programming chads, and it'd be really sweet to have like a group of really kind of like elite devs coming up too. All right, I'm reading these comments. It sounds like there's still interest for the DAO idea, so maybe we'll start work on that. And recent events too. I kind of enjoy, I don't know, do you guys read the like it'd be kind of cool to like talk about like hacks or mistakes or yeah, okay. All right. It would be cool to kind of like go into the like technical analysis, or not technical analysis, like technical investigation of like cool things that are just happening on ETH. Like I mentioned, the Ether rock that got taken was a pretty cool example because it if we've gone for about an hour, but if you guys are interested, I also prepared a solution to this level using Foundry. Foundry is kind of fun. It's like a, instead of using Remix, you could use something like Hard Hat or Truffle, or Foundry is kind of the new kid on the block. It's written in Rust by a bunch of Chads. Should we end it here, or should we keep going and talk about that? Me?
I keep going. Oh, well,
I guess I'll go ahead and do it. It shouldn't take too long. It'll probably take like 20 minutes, whatever. If you are bored, go ahead and head out. It's been nice having you. Otherwise, we'll just keep chugging. Yeah, so Foundry, best place you can read about it is here. Foundry is, a kind of command line tool written in Rust where you can interact with smart contracts, deploy them, whatever. Tests are done really fast in it because Rust is a very fast programming language. The like GitHub and this book is like a good place to like learn about it. And we can solve the entirety of that Ethernaut without ever leaving our terminal, which is kind of baller. So we're going to get a new instance of this level. Cody, you have a question?
Yeah, I was wondering, what would you say are the precursors to today's lesson, like at the most simplest level?
I think if you finish Crypto Zombies, you can pretty much just crush these. Yeah. This is, again, a lot of it is also just kind of like general like computer science knowledge. Like rooting around in the terminal is kind of hard if you haven't like played with it before. If you're kind of non-computer science, like whatever. But that's just one of those things where it's like the more like programming or just general CS that you do, the better. Yeah. Here. All right. Okay, so yeah, Foundry is like Remix, except you can do it all from the terminal. Same thing with like Hard Hat and Truffle. They're just tools that you can, if for those who don't kind of know what terminal is you've got like your apps like down here on my hotbar. Like, your VS Code is a terminal, but instead you could just do that straight from, or is an app, a graphical app, but you can, under the hood, everything is just running on the terminal. So it's pretty important to kind of get used to the terminal and like know what you're doing with it. I'm going to make a new repository, or not repository, a new file, directory, whatever, called Ethernaut 4. I'm going to name it Ethernaut 4 again, and I'm going to go into it. Make dir is make directory, cd is change directory, ls is list, where it shows you what's in it. Oh, whoops, I went to the wrong one. You can see this as an empty repository. I'm going to kind of have this Finder window so you guys can visualize this more easily. You can see it's just kind of empty right now, but then I'm going to do forge init, and then it's going to drop some skeleton pieces in there. Source is where we can stick our contracts. Tests with it, which is within source is where we can have tests. Foundry.toml is like a configuration file. Lib is where we have libraries. This DS test one is the default one that we use to write tests in Foundry. I'm going to go into source and I'm going to make a new contract. I'm going to use Vim. And I'm just going to, not for anything important, but I'm just going to copy paste our solution that we wrote earlier, and I'm just going to drop that into a new file here. So now we have, if I go back into Finder, we have a new, Solidity file here, which I just copy pasted the old solution into. Okay. Then we still have to go through all the steps that we would have done on Remix. So our first step is to compile it. So we do that in Foundry with Forge build. It compiles. It tells me that there's no SPDX license, which is, I should have put license these nuts at the top again. And then we have the hard part about Forge is you have like pretty complicated some command line commands. So again, moving the zoom box out of the way. So to deploy a contract, we use Forge create, and you have like a gazillion different parameters that you need. Or I guess I forget what they're called, options. If David's here, he should make fun of me. So we're going to write Forge create RPC-URL. So RPC, do you guys know what an RPC is? Or not? The RPC, I actually don't know what it stands for, which is not great. Jason, you know what RPC stands for?
Yeah, it's remote procedure call. It's used to do like system calls across networks.
That makes a lot of sense. So an RPC is like what we're actually like pinging or like calling bits on the Ethereum blockchain through. Infura is the biggest one that's like, you could be doing this yourself if you had like a local Ethereum node. But if you don't, you use a provider. Infura is the biggest provider. I'm already logged in. I made a little setup for us. You can, so here I have a project that I'm just going to delete earlier. So I think it's okay that I show you this, where I have some keys and some like endpoints. So I can copy this like Infura endpoint, and this will allow me to like call the chain or interact with Ethereum through this RPC. So I'm going to go ahead and post that there. Okay, and I'm going to go back to one thing. So we need this piece in order to actually be able to interact with it, because otherwise it's like, what am I interacting with? And it'll probably just do like a local fork or something. We need to, because we don't have like MetaMask in our terminal, we have to import our private key. You can do this with -- interactive, which just like asks you later to input your private key. And then you need to specify what file you're compiling. So that's going to be solution.sol. And then you have to specify what contract you're doing within that, which is, I called ours hack. Then we need to say what our constructor arguments were. For us, that's this level instance, if you remember, right here. Put it in quotes. And then you specify what chain it is. So again, we are working on Rinkeby, which is the testnet. And hopefully I did everything right. Oh, I need a private key. I'm using some stupid, you might have noticed that my public key is like leet, which is I generated a vanity address, which if you Google is, you can like generate kind of like key pairs on the fly. Every Ethereum address is just like a key, and if you have a private key that goes with it, this allows you to actually send people stuff, whatever. So if you wanted to, you could copy this, you could import this into your MetaMask, whatever, and steal all the testnet ETH that I put in here, which I won't be too pressed. So I'm gonna go ahead and paste that private key in there. Did I do it? Shit. See if it still works. Oh yeah, it did. Yeah. So deployer is me, and it deployed to this address. So if I go and plug this into the Etherscan Rinkeby, I should be able to go find there. This contract was created here, right? Contract, whatever. I guess it hasn't done anything yet, and nor can I see. Contract, we wrote it and we deployed it onto Rinkeby through Remix, but now we've done it still to Rinkeby, still exactly the same, but we've done it through Forge and Foundry instead. So it still has all these same functions, and now we know the next step is we just need to call Pwn. Instead of calling that through Remix, we're going to again do it through Foundry. We're going to do it through Send, which is how you send a transaction. I'm just copying that. Cast, Send, Cast. So Forge is a tool for like building contracts, and then Cast is a tool for like interacting with the chain, which is cool. So we're now, instead of using Forge, using Cast. We're specifying the chain as Rinkeby. We're sending from. We're going to grab my account again. Thing. Then we need to put interactive again. Then we need to put the address that we're going to attack, which is our instance. Oops. And then we're going to put the function that we're calling. So, and I think I actually need to put this in quotes. Actually, I don't know. We'll find out. This is, earlier I talked about, function signatures. That's what that is, Pwn. And then we have RPC URL, which is our Infura again. Hopefully I didn't mess it up. I'm gonna grab my private key again. I messed something up. Execution reverted. Your chain could be from. Oh boy. And this is why, like people like to get all hackery and try to do stuff like this. And in a lot of cases, it's very useful. But ultimately, it's like you can't underestimate Remix just because like it'll always be good and it will always not have problems and always work. I'm messing something up. -- interactive contract address. Did I change the? Can you guys see what I'm missing? Check pairing again. Do that again. Okay, chain, cast, send, chain, Rinkeby. Did I do that? Yep. From my address. Interactive. Phone. Contract. Address. URL. Let me go check the Forge book to make sure I didn't miss something.
The URL doesn't need to be in quotes, right?
What doesn't need to be closed?
Does the URL need to be quotes or no?
I don't think so. Let me. Active deposit value RPC URL. Yeah, in fact, I should probably get rid of the. I think I deleted one of the I think I deleted one of the characters on the addresses. This one ends in 2C. Okay, that's good. This ends in 80. Huh. All right, I'm not going to hold you guys and try. I'm going to try it one more time from scratch, and then if that doesn't work, I'll try it one other way, and then we can just quit on it. But that is kind of annoying. Let me make sure I copy the right address. And then, so this time I'm just posting the private key directly into it instead of doing the interactive bit, because that's kind of a pain in the butt. There goes the contract address. Function that I'm calling RPC. Did I run out of ETH? Nope. Did I misname it? I don't know. Okay, we will not try to deal with that. However, one other thing that you could do is, I believe you can load in a contract in Remix. So we will have Remix try to save our asses and pull up the contract that it said we deployed, which is right here. And I will I'm not using to check some address. I don't know. I don't want to deal with this anymore. But if that send would have worked, then that would have done the same thing as calling Pwn right here through this button. And that would have been sweet, because that would have been the same as doing it through Remix. And then we could have gone to Ethernaut, submitted it, and it would have worked. One of the problems with messing around the command lines, a lot of times you end up having to debug more your actual commands than the actual code that you're writing. And so that's the reason why using something like Remix is better. But I wanted to put that in there as kind of like, I'm also pretty new to Foundry, so I might be making a mistake somewhere in there, but it's kind of a cool resource for those who are more advanced. And I thought that might've been something cool to talk about, since I wasn't sure where everyone's skill level is. Yeah, but, oh, I just realized I have some, oh yeah, no, not missing chain. Yeah, so I'm gonna go ahead and end it there, unless anyone has any other questions.
Yeah, when are these sessions? How often are these sessions gonna be? So I can be here every time, because I'm learning a lot.
What? So I literally, this time it's on a Saturday at 7 p.m. just because that's like the first number, like date and time I could think of. Like quite literally pulled the number out of my ass. But I guess I should have done this probably when everyone else is here, because I would like to kind of figure out when's the best time for us to do this more regularly. And I hope kind of more as we get more, as everyone kind of collectively gets better, this could become less of a like me lecturing thing. Talking about whatever, and we could just kind of have weekly topics or weekly lectures or whatever. So I want this to be like really fluid and kind of follow the form of whoever. Yeah, I think I lost my audio for a sec, but I try to stop, so hopefully not too much was lost in translation. But whatever form you guys want the most, this can take. So I think I'll probably ping the developers channel in Discord and we can continue the discussion there. But if you have any input now, I'd love to take it.
No, really, I really like this.
Cool. We'll definitely try to do more. I will we can keep the conversation going in devs. So thank you all for coming, and I'll see you all next time.
Bye,
Thanks, Jack.
Jack. See you.
Adios.